urban mobility software. So in this we are going to design our own custom road. So we are going to design our own road structure. For that we are going to find the emission gases for air pollution, or we simply call it as air pollution monitoring. So we call it as air pollution monitoring. So first we will design our own road. So first what I do is, okay, so we will decide one junction here, another junction here, another junction here, another junction, another junction, and another junction. So we will be designing these many junctions, and I will join for example 0, 1, 2, 3, 4 and 5. So totally 0 to 6 junctions, and I want to make a road of it. So here we want to have a road, here we want to have a road, here we want to have a road, here we want to have it, here we want to have it, and here we want to have it. So if you see the location of each of these roads, so let me give, here it is 200, 500 x and y, and here this will be 400, 300. This will be 700, 300, 700, 300, and this will be 900, 500. So 900, 500, and this will be 700, 700, 700, 700, and finally this location will be 400, 700. Okay, so this way we can able to design the roads. So now what we do is, so each lane will have two different roads. Each lane will have two different roads. So I want to make one road like this and another road like this. So what do you do is left and right. So I want to give L01 means connecting the road from L01, then R01. R01 from the right to 01. Likewise I want to connect, and similarly, so all the roads I will make like this. Okay, so all the roads I will make this way. Okay, so this I can do is D05 U05, and this I can give D54 U54. This I can give, and this will be L43, and I can give R43, and this can be U23, can be D23, this can be U12, and this can be D12. So this way I can connect. So even I can draw one more road from here to here, like this also I can connect. So I can connect two different lanes here as well. So in this case what I do is I will make like this L52 and D52, sorry R52. So this way I can able to connect my roads. Now using, after this road is generated, I want to create two files. One is the node file, another is the edge file. I want to create node file and the edge file. So that we will be seeing in our system, in our computer, how we can able to connect the roads. Welcome to Engineering Clinic. So today we are going to see an example on SUMO, that is simulation of urban mobility. Simulation of urban mobility. So in this we are going to design our own new roads, mobility. So we are going to design a custom road. So custom road means the road will be designed by our own self. So how the road will look like is, this is the road. So we have the junctions 0, 1, 2, 3, 4, 5, and each junction will be connected with the two edges. One will be the left to right, one from left, another to the right, so down or up. So that's how the way all the roads are being connected. So now each road will have two lanes. So one lane like this and another lane like this. So we can customize 2 lanes, 3 lanes, like that we can customize. But in this example we are going to have this lanes, and we want to make all our priority junctions. 2 junctions will have the traffic light controller. So we will make 0 and 2 will have the, or 2 and 5 will be having a traffic light controller. So that way we will plan our files. So first thing is we are going to create a node file. First we have to create a file called as a creation of a node file that contains the information about the junctions. So the name of the file is node.xml. Okay, so now in my case, in our machine, I will store all the files in a folder, called custom road. So which is in my home folder. So where do I store it? Home pradeepkumar / custom road. So where I will be storing all my files in my custom road. Okay, so let me create it. Okay, so SUMO demo. Okay, so now let me go and create a file. So first let me go here. So home, I'm creating a folder called as file. Okay, so let me open a terminal. Okay, so what do I do is I create a folder mkdir custom road. So this is my folder cd custom road. cd custom road. So now pwd, I am inside this folder /home /pradeepkumar custom road. So this is where I am going to store all my files. Okay, so now how to generate this file is, so we have the locations, everything. So .node.xml, we can search in the net node.xml file SUMO. When you check it, this SUMO documentation will be here. So we can make use of the documentation. So in this documentation we have this node.xml file. So okay, see that this is the node.xml file. So first what I do is I will just copy this. So first I will create a new file. So this is my node.xml. So we have an ID here. So node 0, 1, 2, 3, 4 like that, we have an ID. So we want to create this ID here. So now what I do is I'll just create, totally we have these many IDs. Okay, so we'll go into custom road. In the custom road I'll store this file as file dot, I can store this as file dot node.xml. So this is the name I'll be storing for this file. Okay, so totally now I want to name all the thing. So now we want to generate traffic light and priority. As of now we are going to do only with the 2 things, traffic light and priority. Okay, so now as per this design we will design the road. So first we will make the node ID. Node ID we want to get 0, 1, 2, 3, 4 like that. We have the 6 IDs. So 0, 1, 2, 3, 4 and 5. Okay, so totally 5. So in our case we want to make node number 5 and node number 2, the junction number 2 and 5 to be enabled with the traffic light. So 2 and 5 will be traffic light. So already we have this here. So copy this number 2 and number 5. So these 2 are traffic light controllers. Okay, right. So all others are priority junctions. So anyway, the priority junctions, this extension I will delete all these extensions. The commenting lines, so for bigger size I'll just delete that. So all other things are priority junctions. So priority here, only two junctions are traffic light, remaining all priority junctions. Okay, now regarding the x and y values, so we need to set the x and y values. So they have given -500 like that. We use as per this. So number 0 is 400, 700. number 1 is 700 700, so 0 is 400 700, and this is 700 700. So as per the logic how we designed it, x axis y axis. Okay, now this is 200, number 2 is 900 500, so 900 500, number 2. Number 3 will be 700 300, 700 300, number 3. Number 4 will be 400 300, 400 300. Number 5 will be 200 500, 200. Okay, so now we have created the the road junctions, the junctions we have created. So this is the node.xml file. So now this concept is very easy to create. So we have created the node.xml file. So I'll just copy this and then put it in this help file. So this is the node.xml file. The next two is we have to create the edges. So roads connecting the junction, that's what we call it as the edges. Now in this case what we have to do, we have to create the edges file. Now again I'll go back to the internet where this logic here. So the edges file, so we just go back here. Yeah, these are the edges. So now how many edges we have, we'll calculate that. Now we'll just copy this here. So Control T Control V. So now we'll save this as file.edge.xml, file.edg, or whichever name you can give. I will give only 3 letters, so I give XML here. The same custom road I will just define it. Okay, edge.xml. So now in this case how many lanes we want to have, or what speed we want to have, so all these things we can able to design upon this thing. Okay, so now I will just go with this. Now we can see here 0 to 1 we call it as L01, 1 to 0 we call R01. So likewise we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14, totally 14 edges are there in this. So totally 14 means only 7 are there. The number of lanes will be also be there. So from 1 to M1 like that we are connecting, and M1 to 1 also we can able to use that. So that way we can able to plan it. Okay, so edge ID, so how many edges we will see, 14 edges, 1 2 3 12. So we'll take 2 more, we'll copy paste it. So now what we do is we'll change the name of the edges. So I'll go with the smaller, the smaller number. So L01, R01. So this way I can able to do. L01 is connecting 0 to 1. So from 0 to 1. So already we have it 0 to 1. So priority is 2. Number of lanes is we can have 1. So number of, if you want to make within 1 lane, if you want to make 2, we'll have 2 here also. So we'll have 2 lanes here. So everything will be 2 here. So we'll make everything to 2 lanes. So let the speed be constant as it is. So it is meters per second. So 11 meters per second. So which will be the high things. Okay, now priority also will have this way. So L01, R01 is done. Now like we'll make into 2 at a time. So what we'll do is we'll make 2 at a time. Okay, so 2 at a time we'll take. So L01, R01. So next thing is U12, D12. So we'll make this as U12, D12. So U12 connect from, so okay, R01 connect from 1 to 0. 1 to 0. So 1 to 0 we have 2 lanes, and 0 to 1 we have 2 lanes. So that means totally it will be a 4 lane road. So 0 to 1, 1 to 0. So number of lanes in each case is 2. We'll get 4 lanes. Okay, so that's how the way it is. So next thing is U12, D12. So U12 will be 1 to 2. U12 will be 1 to 2, and this will be 2 to 1. Okay, so 2 to 1, so that will be done. Then 2 3, so 2 3 means it is D23 U23. So D23, which will be easy to handle it, D23. So D23 will be 2 to 3, and this will be 3 to 2. So 2 to 3. Okay, so this way we can able to plan. Then next thing is L43 R43. So L43 R43. So L43 will be 3 to 4, and this will be 4 to 3. Okay, so this way we can have it here. And priority, let us say priority 1 to 3. So let it be as it is. Let the priority be without disturbing. We'll add 1 to 3. Three priority lights. Next thing is D54 U54. D54 U54. So D54 will be 5 to 4, and this will be 4 to 5. 4 to 5, and let it be. And next thing is D05 U05. So D05 D05 U05 U05. So D05 will be D05 will be from 0 to 5, 0 to 5, and this will be from 5 to 0, 5 to 0. Okay, then finally we have one more thing is last one is between 2 to 5, L52 R52. So we have L52 R52 R52. So L52 connecting 5 and 2 and 5 2, and this will be 2 5. Okay, so the number of lanes is 2 across all these things. If you want to give only one road on one side, you can give number of lanes to be 1. If you want to give 3 roads, you can be able to give 3 roads just to configure our own roads. Okay, so now we have done this the second file. So I will just copy paste in our help file. So this help file I will just copy paste here. So this is the edges.xml file. So next thing is we have to create a network. So using the nodes and the edges, we have to create a network net.xml file using this command net convert -n file.node.xml and -e edge.xml and -o is the output file.net.xml. So now let me run this command. So net convert, already we have installed SUMO here. So because of the SUMO is there, so the net convert command also will be installed. -n file.node.xml -e file.edge.xml, then -o file.net.xml. So once it is done, success. So we got that this file is got created. Now when you check this file, I will open this file here directly in the custom road file.net.xml. See that? So this is the complete network file is got created. So automatically SUMO creates this network file. Okay, so this way we have just created the network file. Now this file generate a configuration also, we will see that as well. So network file is got created. Okay, so now this is automatic generated, that file is created. So now this is the step 3. What we have done is the location of the file, everything is here only. Now we have to create a random trip. So now we want to make some vehicles to run on the road, so that those vehicles will emit the air pollution gases. The air pollution gases, namely carbon monoxide, carbon dioxide, hydrocarbons, particle matter, and nitrous oxide. All these things categorize the the possible chances of air pollution. So all these gases, how these vehicles emit, that is what we are going to model in this simulation. Okay, so for that SUMO has one option called as randomtrips.py. There's a file which is there in the tools folder. Now we have to run this tools folder, this file with the help of this file.net.xml and file.root.xml, and these things we have to run it. So we will create a root file, it will be creating, and the begin and end. So what time the simulation is starting and what time the simulation is completing. So that also we have to mention it here. Now this is what we are going to run in this random trip. So random trip file will be, output will be on this root. So root.xml file. Now this command we have to run. Now it is there in the SUMO 1.4.0 folder. Now how do we run it? I'll go here. So now we have run it. Python 3 home pradeepkumar SUMO. So I have the folder name SUMO tools. Then I have random trips. So you can see the random trips.py. Now -n file dot net dot x file dot net dot xml. Net.xml. Okay, fine. Net.xml, then -r file dot route.xml, then -b 0, then -e 1000 and -l. So once you run it, it will create a root.xml file. You can see that the root.xml file is created. Now click ls, check ls. You can see file.root.xml also got created, and apart from that there is a trip file also created. So trips.trips.xml. Now let me open those files. So trip.trip.xml and file.root.xml. You can see this is the trip. So at what time it departure, the file will be departing, from which line through which length it will go. So everything will be generated. Now next thing is this root.xml. This is how the way the root will be generated. So this file also will be generated. So this is the root and vehicle ID where it goes. So all this information will be generated like this. Okay. So this is a simple example of how this can be easily written over it. So now next thing is we have to generate a configuration file. So for that we have to create one file manually. We call that file as a configuration, SUMO configuration file. So now you can see step 5 here. Create a file called file.sumo.config to run with the SUMO for air pollution. So now we have to create a file. Now I have already given the format here. So from here to here you copy this. So Control C you copy. Then open a new file, Control V. So you can use file.sumo.config. So you can give the name as file.sumo.config. Now this is the input file. Now we have the file.network file which is there, and file.root.xml. So the same naming you have to follow it here. So all the files, and begin value 0, end value 1000, and the step length value is 0.5. If you want to make a longer simulation, you can give 0.1 here. So every time it will be 0.1 incremented. So now if you want to give 0.5, every time it will be 0.5. If you want a smaller simulation, you can give 1.0 also here. So this is the time configuration and the configuration file. So now this step is also done in this file. So this we have created. So now finally we have come to the GUI part. So now when you want to run the GUI, so sumo-GUI file.sumo.config. So once you run it, you can see the simulation. So this is what the simulation what we got. So you can see here each lane has each road has 2 lanes. You can see here, and see the traffic light here. So we have generated traffic light here at this junction. So this junction has a traffic light. So you can see both the sides are enabled with the green signal, and this side is enabled with the red signal. Okay. So now if these lines, when you see this traffic signal, it doesn't have anything, so no traffic lines are here. And when you see this traffic, yeah, this also have a traffic signal as per the logic what we have built it. Okay. So now we want to run the simulation. So I want to run the simulation in step. So I will give 400 time units. Then I run the simulation. So totally for 1000 seconds the cars will be running. You can see here. I'll go with the real world. Real world means you can see the car actually as it is. So you can see here. So the cars are running on the roads. So there are 2 lines here. So the cars are running on the roads. So actually it is a keep right traffic. That is mostly the right traffic. Okay, it is in American standards. So it is not Indian. Road condition, the UK road condition. So UK always go for a keep left. That is a left hand traffic and right hand traffic. So we have 2 categories. So this is how the way the vehicles are moving. You can see at the signals how the vehicles are waiting at the signals. You can see whenever there is a red color, red indication, the cars will be waiting in the queue one after the other. And now see that there is a yellow changing here, and that is how the way the vehicles. But our simulation is not on this aspect. Our simulation is on the aspect of calculating the emissions. So how much these things are emitting. So for that we have to have a command. So this feature tells you that how the vehicles are running on the road, just to see whether how your design is working fine. So this is for this example. Now this thing I want to make a run in the SUMO, not a GUI, but in SUMO I want to create this command here. Now I'll run one after the command here. So now first what I do is I'll clear the screen, sumo -c file.sumo.config, that I have done. Next thing is we have emission output. So now first our purpose is on emission output. You can see this is emission output. So double hyphen emission hyphen output. Then the file name is emission.xml. So we want to create a file name called as emission.xml, where all the emission record will be stored. Next thing is we want to create the battery output. So in case if your vehicles are electric vehicles, you can create a battery, but anyway let us not go into that. And the FCD output car.xml. So I want to create a floating car data output. FCD means floating car data. I want to get a floating car data output. Let me use car.xml file. Then summary, I want to take the complete summary of it. So then I can use a summary output, SUMMARY summary hyphen output. Then I can give a summary.xml file. Okay. So then collision, if we want to know any collisions happening, if the vehicle hits with other vehicle, that kind of collision information I can able to get on the collision information. So if you are doing some research in accident information, then you can able to use the collision information. Collision output colli collision.xml. So this way I can able to give. And statistics, let us not, okay, let me see some statistics here. Statistics, statistic output, then stats.xml will create like this. Now once you run it, all the files will be created. So we have emission.xml file created, car.xml will be created, then summary.xml will be created, and stat.xml will be created, and collision.xml will be created. Now you can see that now these things are being created now, because our simulation is totally 1000 seconds, running for 1000 seconds. So yeah, it's done. So you can see that for every step 50, 100, 150 like that, for up to 1000, the how much time it took, and real time traffic how much it has, and everything got created. So now you can see that we got many XML files, summary.xml, then car.xml, collision.xml, emission.xml, like that we have many XML files. But please remember, XML files are always not easy to handle it, because we need some parsers to handle XML files. So in case if you want to convert the XML files into CSV file, that's how we do. So to convert the XML files into CSV files, here is the step. Okay. So already the Python, already in SUMO we have a file called as XML to CSV. There is a file available, XML to CSV. So that file we can make use of it to do that. Okay, now in my case it is only SUMO, not SUMO 1.4.0. So in case if you are installing it, you just check accordingly. So in my case it is SUMO, but when you install it might be SUMO -1.4.0. So check it accordingly. So now this XML to CSV I want to run it. I want to create a file called as emission.csv. The output is -o. So this is what I am going to do now. Now let me do that now. So Python. So whenever you want to use the SUMO files, you have to put the full path, complete path. Now when I use home, pradeepkumar, SUMO, then tools, then XML, then XML to CSV. So csv.py, emission.xml -o, emission.csv. So when you do that, it converts the emission.xml into emission.csv in just some time. In some just 10-15 seconds it will create it. I'll show you the emission.csv file. So how the carbon monoxide, carbon dioxide data, all these things, how it. So we will find out in where the emission is so high, and in which road the emission is too high. That also we can able to find out. Okay, so now this is done. Now again we will go with one more file called as car.xml. So car.xml -o, car.csv. Now this also will convert all the XML files into CSV file, so that we can easily process the CSV file in a Excel sheet or any LibreOffice software. So CSV means comma separated values. Okay. Now summary. We have one file called as summary. So So then I can use the summary.xml. Yeah, so summary.xml, nothing here. I think stats.xml. Okay, so next thing is collision. If data is not there, it will be very easy. It will be faster, I think. Collision. Yeah, so okay. So now let me go into the folder here. In this folder, custom roads. Okay, now you can see all the files are here. So now we can see the collision.csv file. Okay, the collision, nothing is there, so no issues. We will go with the emission.csv file, which is having a huge number of values in the emission. You can see the file is being opened now. It takes some time because the number of record is too high, so it takes some time to get processed. Okay, so now we can see here CO is vehicle carbon monoxide, then vehicle carbon dioxide, vehicle hydrocarbons, vehicle nitrous oxide, vehicle particle matter. So and vehicle angle is here. So E class. So here it is European Union. So now in India we have Bharat stage 6 now. Likewise they have a European Union 4. The stage is 4. So that's what it is showing, the emission norms, Euro norms. And the vehicle fuel is this much. Vehicle ID is this, and the vehicle lane is this. So in R52 we have 2 lanes, R52 0 and R52 1. So we have 2 things. So likewise it will be showing you which lane the emission can be more. That also we can able to process in this. And vehicle noise, it will tell about the noise, and vehicle position, then vehicle speed also it will tell you the speed, then vehicle weighting. So default everything is a car, so we have a car. Now in case we want to make buses, trucks, motorcycles, bicycle, those things also we can able to include it here. Then vehicle X and Y, so which direction the vehicle was running. So this is what the total information. Now in this case, if you want to use insert pivot, if you want to use a pivot chart, so then I can create a new chart here. Yeah, so now you can see here the filters are here. So now vehicle lane I can use it, and in the row field I can use vehicle carbon dioxide, then vehicle carbon monoxide, then vehicle hydrocarbons, then nitrous oxide, then particle matter. Now when I click OK, so because of the huge number of data, the file takes some time to get loaded. So I can see all lane vehicles. So we can have now D54 1. Now D54 1, what happens here? So vehicle carbon monoxide is how much? So this information we can able to find it out on D51. So what is the value of this carbon monoxide and other thing? So likewise we can able to find out using this pivot chart. So this is the example of how we can able to analyze the value of this emission norms, so the emission gases. So in this example what we have seen is the emission examples here. So we have got all the files here. Now one more file, collision is not there. Then stats, we can see the statistics. So only one statistic is number of vehicles is totally 999 vehicles, loaded vehicles is 1000, running vehicles are 292, when one vehicle was waiting, and that's all. So this is the statistics. Then finally summary will be there. So this is a total summary. So how many steps arrived? So the vehicle number, so this is the total summary of this simulation. Okay, so in case we want to plot the characteristics, we can able to plot, but this example is just to show you the emission norms. So this example just to show the emission data of floating cars in SUMO simulation. So this is what we have done. So the roads designed were designed designed by the roads are user designed. The roads are user designed roads. Okay, so this is what here. So hope you like this video. So if you want to listen to more videos of this kind, you can please subscribe to my channel and share it to your friends, students and research scholars. And thank you very much. Thanks for watching. So to download all the source codes here, so github.com/tspradeepkumar, and you can also follow my website https://nsname.com. So all the source code, everything, whatever I use, it will be a free of cost, but sometimes some videos might be only for the memberships. So in case if you need the membership, you can purchase the membership. It starts from just $1.5 or just rupees 99. It starts from it. Thank you. Thanks for watching.